What's up, guys? So today we're going to learn about how to write binary ionic formulas. We're going to start with the representative elements, and we're going to use lithium and oxygen. So Li. So if you look at the periodic table, you know that oxygen needs 2 more valence electrons to fill its outer octet. So, and lithium can give it 1. So you need 2 lithiums to fill oxygen's octet, and that's how you write that. So then you're gonna write the name, which will be that. So you just lithium and oxide. You want to end it IDE. Just forget about the number right there when you're writing it out, and that's it.
What's going on, guys? Mr. Koestel here. Today we're going to continue our talk about binary ionic formulas, but this time we're going to use the polyatomic ion. So let's start out with our polyatomic ion, phosphate. And then let's use our representative element, calcium. Now these two form calcium phosphate. Now here's how you write that out. Now the reason you write it out like this is because phosphate, its formula is with a 3 negative charge. So you take this 3 negative and put it down here on calcium. Calcium has two electrons to give up. So phosphate, you take this 3 and you put it down here for calcium. You take the PO4 and you put it here, and then the 2 that calcium gives up, you put right here.
What's up, guys? So we're going to continue on with our talk about binary ionic formulas, but we're going to go on to the transition metals. And so we're going to use copper and oxygen. So copper is Cu, and oxygen is O. And so you need oxygen needs 2 more electrons to fill its octet. So there you go. And then that's it. So then we're gonna go on to write in words. So yeah, copper, oxide. All right. So again, forget about that number right there. And so it's like a understood 1 right there. So, and when you write it with transition metals, you need to have Roman numeral in there. And so, copper 1 oxide. There you go. So guys, so we're gonna continue on our talk about binary ionic formulas, and we're gonna talk about which elements are gonna form ionic bonds. So if you look at the periodic table, the elements that are further apart from each other are going to form ionic bonds, but the elements closer together are going to form covalent bonds. For example, like lithium fluoride, that's an ionic bond right there. If you look at the periodic table, they're very far apart. Another example would be like lithium oxide, but you need 2 lithiums. So elements that are further apart on the periodic table are going to form ionic bonds to fill their octets, and that's it.
What's up, guys? Mr. Koestel back at it again. Today we're going to talk about binary molecular formulas. What causes a binary molecular formula or covalent formula as its most common name? If you look at the periodic table, it's elements that are close to each other. So we have nitrogen and oxygen, and if you look at the periodic table, they're close to each other. So these 2 form dinitrogen tetraoxide. And so if you look at this is all the prefixes that you use for the numbers. So you put the name in front of it. So you put the prefix in front of the first. It would be dinitrogen. Fix that in. Dinitrogen. This would be just regular. I mean, it wouldn't be regular. You still put the prefix in front of it. So it'd be tetraoxide. Now you still put the I at the end because it is that second one. So that's how you write it out, guys.